Okay, so I'm going to do this for the elastic collision. In the elastic collision, they are not moving together.
Continue.
For elastic collision, they are not sticking together. So for that purpose, I reverse it before it stick together. Before it stick together. Now we have put magnet inside. So when one card comes in, it will repel each other. So it's like a perfectly elastic collision. So here the car 2 is at rest. That means initial velocity of the car 2 is 0 all the time. And when I push this, there is the initial velocity for car 1, and after the collision, this will move and that will also move. So we need to measure two velocity, one for card 1, one for card 2. So the motion sensor will measure the velocity for this one, card 1, and for card 2 we have here a photo gate here. So as soon as something goes in, it's a timer, then it can record how long it took to block the signal here. There is a infrared signal going on. You can see the.
Can you show how it records?
You can see.
First, set a time.
So this should be at the gate, and then reset. Reset is now 0. So if I move this, as long as this is within that range, it will count. It will start the time, and then as soon as it passes, it will stop. So we can see how long it takes from this end to this end. So let's do it. So it's already reset. If I move, you can see the timer changing here. Okay. So that 0.047 second is time it took to move from here to here.
To cross
Pass
the
this
photo
port.
gate.
So if you know the distance, and you know time, then you can calculate the speed of this car. Okay, so I'm going to measure what is the diameter of this using a vernier caliper here. So diameter here is 9.5 millimeter. 9.5 millimeter. So it should go. It should go here in the data sheet. Length of the flag L. The mass of empty car, mass of empty car 2, mass of load are same as our first experiment. All right, so let's do the same thing. So first part is no load. So mass of the car, this is the part 1, this is car 2. So I'm going to push here. Let's start this and make sure we need to reset this. So collect and then push this. Okay, so time collected here is 0.0253 second.
Okay.
So you have to record that in for the calculation of velocity of the card 2. And for the card 1, we can do the same thing here. What's the speed of the card before collision and after collision? So speed here is before collision. So let me cover more time here. So speed here is 0.38 meter per second from position versus time. Here is 0.383 from velocity versus time. And after collision is close to 0. It's also close to 0. So you also saw cart 1 actually almost stopped after collision. And for the velocity of the cart 2, distance is this diameter of the post and time is 0.0253 seconds. So that should go here in the data set, just like we did in the first part. So take the average, calculate the momentum, and also calculate the average velocity and what's the theoretical values. And for the cart 2, from time and the velocity, calculate the momentum and also calculate the percentage change. So I'm going to repeat the same experiment, same trial, by changing the mass, by adding the mass one time in the cart 1 and one time in the cart 2. Okay? Alright, so I'm going to reset again here. Cart 1 has the added mass. Cart 2 is same here. Let's reset this and we're ready to go. So collect, reset. Okay, so both of them are moving at this point. So here for the cart 2, time is 0.0273 second. So cart 1, from position versus time, it's before. This is before collision and this is after. Before collision, 0.2689 if one meter per second. From velocity versus time graph, it's 0.269. After collision, it's 0.072 meter per second, and from velocity versus time is 0.074. So take the average of them, and you have to enter in the second row and calculate everything like before. So now third trial is the same here. So I'm just going to move this load here and here. This is reset here. Now collect and ready to go. Okay, so you might have seen the cart 2 actually came back. And let's see what we'll get from the graphs.
What's the time now?
So for the cart 2, time it took is 0.0329 second. So that's the velocity after collision for the cart 2. For cart 1, so let's calculate here. This is position versus time graph. The slope is 0.499. That's the velocity before collision. From here, it is 0.4945, very close. After collision, the slope is negative. And this value is also negative, see below the 0. And it's 0.073. This is 0.0716. It's pretty close. Look at this is negative slope. This is negative number. That's because the cart 1 actually moved back after the collision. So that has to go here in the third trial. So calculate all those momentum, take the average first, and then also you have to calculate theoretical values for the cart 1 and also cart 2, and compare what's the change in the percentage compare with the theoretical prediction.